7:46 in the evening on July 31st, 2026, and across Naples, thousands of people are still celebrating in the streets, marking the centenary of their beloved football club, SSC Napoli. Then the ground moves, not a gentle tremor. A long, rolling shove that rattles windows, sets off car alarms up and down entire neighborhoods, and sends chunks of a nearby cliff crashing down onto parked cars. Within minutes, thousands of people who were celebrating are instead standing in the streets, phones out, checking on family, checking the news, asking the same question a lot of people west of Naples have been quietly asking themselves for the better part of 2 decades. Is this the one? Is this finally the sign that Campi Flegrei, the sleeping volcanic system sitting directly underneath 500,000 people, is finally waking up? Today, we're breaking down exactly what happened in Naples that night, why this specific earthquake and the swarm that followed it are being described as the strongest seismic activity this volcanic region has produced in 40 years, what the actual current scientific understanding says about whether this points toward an eruption, and why the honest answer to that question is more complicated and less alarmist than the headlines suggest. No exaggeration, no sensationalized countdown to disaster, just the geology, the historical record, and what scientists who have spent decades monitoring this exact volcano are actually saying right now. Before we get into it, if you're anywhere near Naples, or if you've ever visited the Campi Flegrei area, drop a comment and tell me what you know about this volcano, because I'd guess most people who don't live there have genuinely never heard of it, despite it sitting directly beneath one of Italy's largest metropolitan areas. And if you want to keep tracking this situation as INGV releases new monitoring updates, subscribe to the channel now, because this is exactly the kind of slow-moving geological story that can shift quickly. Let's get into it. Here's exactly what happened on the night of July 31st. At 7:46 p.m. local time, a magnitude 4. 7 earthquakes struck the Campi Flegrei volcanic area, with its epicenter located near the Solfatara crater in the town of Pozzuoli, at a shallow depth of roughly 3 kilometers. Italy's National Institute of Geophysics and Volcanology, known as INGV, confirmed almost immediately that this was the strongest tremor recorded in this specific volcanic region in 40 years. The shaking was felt sharply not just in Pozzuoli itself, but across the western districts of Naples, including Bagnoli and Fuorigrotta, reaching all the way into the city center and on the nearby islands of Procida and Ischia. At least 21 to 26 people were injured. According to different reports in the immediate aftermath, several unoccupied buildings collapsed and part of a cliff face crumbled, crushing cars beneath it. Rail service across the Naples network was temporarily suspended, and the port of Pozzuoli was closed, cutting off ferry service to Procida and Ischia at exactly the moment many residents wanted a way to leave. The main shock was just the beginning. INGV confirmed at least 10 aftershocks in the immediate hours following the main event, with the largest reaching magnitude 3. 8 at around 10 p.m. that same night, striking in the Gulf of Pozzuoli. By the following day, seismographs had recorded more than 60 separate aftershocks total, part of what local reports described as a swarm of more than 30 tremors moving through the region that evening alone. Italy's Civil Protection Minister, Nello Musumeci, publicly warned that the seismic swarm was continuing and that further earthquakes above magnitude 3 remained a real possibility. Many families, understandably rattled, chose to spend the night outside or sleeping in their cars rather than risk being indoors if a larger aftershock struck, a precaution that emergency officials have generally supported, given that the period immediately following a significant earthquake carries the highest statistical likelihood of a large aftershock. To understand why an earthquake at Campi Flegrei carries such a different weight than an earthquake almost anywhere else, you need to understand what this place actually is, because most people, including plenty of Italians, don't fully grasp what's sitting beneath their feet in this specific stretch of coastline west of Naples. Campi Flegrei, which translates to the Phlegreian Fields, is not a single mountain the way most people picture a volcano. It's a vast volcanic caldera, nearly 12 kilometers across, formed roughly 35,000 years ago when the ground collapsed following a colossal eruption known as the Campanian ignimbrite, one of the largest volcanic events in European history. Half of this caldera now sits submerged beneath the Gulf of Pozzuoli, and the land portion is pockmarked with 24 separate internal craters and volcanic features, none of them looking anything like the classic cone shape most people associate with volcanoes. This is precisely why so many people live directly inside an active volcanic system without fully registering that fact day to day. There's no looming peak to remind them. There's just ordinary neighborhoods, ordinary streets, ordinary life, sitting inside the collapsed remnant of one of the most powerful eruptions the continent has ever produced. Roughly 500,000 people live within the specific municipalities that make up what Italian authorities officially designate the caldera's high-risk red zone, and the broader Naples metropolitan area surrounding it holds close to 3 million people total, making Campi Flegrei one of the most densely populated active volcanic regions anywhere on Earth. The last time the system actually erupted was in 1538, when a new volcanic cone called Monte Nuovo, meaning New Mountain, burst up out of the ground and grew to 130 meters in height in just 8 days, an event still recognized as the youngest mountain in Europe. Ground uplift around the town of Pozzuoli had actually been observed by residents as early as 1502, and modest seismic activity was recorded just 2 days before that 1538 eruption finally occurred. Now, let's talk about the specific phenomenon driving what's happening right now, because understanding it is the key to understanding why scientists are watching this swarm closely without necessarily treating it as evidence of an imminent eruption. The process is called bradycism, from the Greek words for slow movement, and it describes the gradual rise or fall of the ground surface in a volcanic caldera, driven by pressure changes deep underground as magmatic fluids and hydrothermal gases shift within the volcanic system. At Campi Flegrei, this isn't some new or unprecedented phenomenon. It's the caldera's defining signature behavior, and there's a remarkable piece of physical evidence you can go stand in front of today that proves it. In Pozzuoli, at the site of what's popularly, if inaccurately, called the Temple of Serapis, actually the remains of an ancient Roman marketplace, 3 marble columns still stand with visible boring holes carved by marine bivalves, small shellfish that only burrow into stone that sits submerged in seawater. Those boring marks appear up to 7 meters above the column's current base, providing a 2,000-year physical record of this ground rising and sinking over and over, long before anyone had modern seismographs to measure it. The current phase of unrest at Campi Flegrei began around 2005, and it has been slowly, steadily intensifying since. Since that year, the ground near the center of Pozzuoli has risen by more than 140 centimeters, well over 4 feet of measurable uplift, and the rate of associated seismicity has climbed alongside it. This isn't the first time in the modern era that this caldera has gone through a significant uplift and earthquake episode either. Documented uplift crises occurred in 1950 through 1952, again in 1969 through 1972, and then in a particularly intense crisis from 1982 to 1984. That 1980s crisis is the specific historical benchmark being referenced now because it produced ground uplift of up to 1. 8 meters in the central caldera area and more than 16,000 individual earthquakes. An extraordinary number, all without ever culminating in an eruption. During the peak months of that 1980s crisis, monitoring recorded more than 1,300 earthquakes in a single month, with uplift rates reaching as much as 9 centimeters in a single month. That 1980s crisis is genuinely worth understanding in detail because it offers the closest historical parallel to what officials are worried about today, and because it teaches an important lesson about the difference between genuine volcanic unrest and an actual eruption. The uplift and earthquake activity during the 1982 to 1984 crisis was severe enough that Italian authorities made the decision to forcibly evacuate tens of thousands of residents from Rione Terra, the historic hilltop district of Pozzuoli, believing the sharp upswell in ground level might be signaling an imminent eruption. Police and military personnel physically removed people from their homes. Those residents were relocated to new apartments elsewhere, and the district itself was permanently seized by the state. Today, tourists wander the still largely empty streets of that historic quarter, its buildings beautiful, well-preserved, and mostly uninhabited. A strange, quiet monument to a crisis that, in the end, never became an eruption at all. Scientific reconstruction of that period has since suggested the underlying cause was likely tied to the specific thermofluid dynamic behavior of the hydrothermal system beneath the caldera, rather than magma actively forcing its way toward the surface. Though this remains an area of ongoing scientific study and debate, particularly because a competing model at the time, which explained the uplift as instability caused by rising pressure directly from the magma chamber below, was the interpretation that actually drove the evacuation decision. Italy's Department of Civil Protection has been explicit in its own official comparisons between that historical crisis and what's happening now. Their assessment states that the current situation is marked by ground uplift and earthquakes of a magnitude genuinely comparable to what was experienced during the 1982 to 1984 Brady seismic crisis. But in terms of actual impact on buildings and infrastructure, they note the current scenario looks very different because the frequency and severity of damage seen in the 1980s, particularly across Pozzuoli, simply hasn't been repeated at the same scale so far. A difference they attribute partly to changes in building vulnerability and partly to how this current episode has evolved in terms of quake frequency and uplift rate compared to 4 decades ago. So where does the July 31st magnitude 4.7 earthquake fit into this longer arc? And what does the science actually say about what it means going forward? This event displaced a magnitude 4.6 earthquake from June 2025 as the strongest tremor of the current. Ongoing swarm, which INGV data shows, has actually been building gradually since around 2015, with a noticeable intensification beginning in 2023 and continuing in pulses since. In addition to the seismicity itself, INGV monitoring confirms the volcano is also currently inflating, and that the flux of carbon dioxide escaping from the ground has been increasing as well. Both signal scientists track alongside earthquake activity as part of a fuller picture of the system's behavior. Based on all of that combined monitoring data, INGV currently keeps Campi Flegrei at an alert level of yellow, meaning attention, one step above the baseline green level and below the more serious orange, or pre-alarm, and red, or alarm, levels that would indicate authorities believe an eruption has become genuinely imminent. INGV's own public messaging following the July 31st earthquake has been direct and consistent on this specific point. There is currently no immediate indication that this earthquake will trigger an eruption. The agency has stated that the seismic activity recorded so far remains within the range of normal Brady seismic fluctuation for this system, and, critically, that scientists generally expect an actual eruption to be preceded by a different, more intense, and more persistent set of warning signs than what's currently being observed. Signs that would likely include a marked, sustained acceleration in uplift rate, a significant and sustained shift in the composition or temperature of gases being released from the ground, and earthquake activity that migrates in specific patterns consistent with magma actively forcing its way toward the surface, rather than the kind of swarm activity tied to hydrothermal and tectonic stress that has characterized this unrest so far. That said, and this matters just as much as the reassurance, official Italian planning treats this seriously precisely because Brady seismic crises, even when they don't end in eruption, can still cause real dangerous damage on their own, through structural stress on buildings, landslides, and rockfalls exactly like the one that crushed cars in Pozzuoli on July 31st, and the simple cumulative danger of repeated strong shaking hitting the same vulnerable structures again and again. Roughly 2 years before this latest earthquake, the Italian government had already announced updated measures specifically responding to the area's rising seismic activity, including a refreshed emergency plan for a possible mass evacuation of the red zone, an area covering 15 municipalities and more than 500,000 residents. Civil protection authorities coordinate this planning jointly with the Campania regional government, the INGV Vesuvius Observatory, and local municipal governments, organizing their response around clearly defined phases: attention, pre-alarm, and alarm, each with specific triggers and specific actions attached, precisely so that any genuine escalation toward eruption risk gets a proportionate, pre-planned response rather than a chaotic, last-minute scramble. It's worth being honest about the layered risk here, because it isn't simply eruption or no eruption. Even without a magmatic eruption reaching the surface, the hydrothermal system beneath Campi Flegrei is capable of producing what scientists call phreatic activity, essentially sudden, localized steam and gas explosions driven by superheated groundwater flashing to vapor when it contacts hot rock or rising gas, events that can occur with very little warning and that represent a genuine, separate hazard. Scientists continue to monitor closely, distinct from the much larger and more consequential question of whether magma itself is moving toward the surface. So what should you actually take away from all of this? The July 31st earthquake was genuinely significant, the strongest recorded in this specific volcanic region in 40 years, part of a broader seismic swarm that has been intensifying since 2023, within a longer unrest episode running since 2005. It caused real injuries, real damage, and real justified anxiety for the roughly 500,000 people living in the most exposed communities. But the specific current scientific assessment from the agency responsible for monitoring this volcano around the clock is that this earthquake sits within the range of what this particular caldera has produced before during past Brady seismic episodes, including a 1980s crisis that was, by some measures, even more intense than what's happening now, and which ultimately subsided without an eruption. Unrest at Campi Flegrei is real, ongoing, and worth taking seriously. It is not, based on everything scientists are currently observing, the same thing as an imminent eruption, and the two should not be treated as synonymous, however dramatic a single night's headlines might read. If you live in or are planning to visit the Naples area, the practical guidance from Italian civil protection remains straightforward and hasn't fundamentally changed because of this earthquake. Know the standard earthquake safety response: drop, take cover under sturdy furniture, and hold on, and stay away from windows and exterior walls while shaking is actually happening. After shaking stops, expect aftershocks and avoid entering any building that shows visible new damage. Follow official updates, specifically from INGV and Italy's Civil Protection Department, rather than secondhand social media speculation, since this is precisely the kind of story that tends to get dramatically inflated as it spreads. None of that changes because of a single earthquake, however large. What has changed is that everyone monitoring this caldera, and everyone living inside it, now has one more significant data point in an unrest episode that has already been unfolding for 2 decades, and that data point will keep being analyzed alongside everything else scientists are watching in the weeks ahead. We'll keep following this story as INGV releases further monitoring updates, and as scientists assess whether this swarm continues, intensifies, or begins to subside, the way past episodes eventually have. If this breakdown was useful to you, subscribe so you don't miss the next update out of Campi Flegrei, because this is exactly the kind of long-running geological story that deserves careful, ongoing coverage rather than a single alarmist headline. Drop a comment if you've ever visited Naples or the Campi Flegrei area, and let me know if you knew what was sitting beneath it. Stay informed, stay curious, and I'll see you in the next one.